In this video, I'm introducing integration by parts, which is a type of integration that we will be using when we have a product of two different functions that we have to integrate. So as an example, in this first problem that we're doing, we have the integral of 8x, and that's being multiplied by e to the 4x. So that's a product. It's the integral of a product. And the 8x is algebraic. It's such as some power of x. And the e to the 4x is exponential. So in this video, we're going to be looking at products that have an exponential part and an algebraic part. And so here's how we want to go about doing this. I'm going to introduce what is called the tabular method of doing integration by parts. And in this video, once again, we're going to have an algebraic part and an exponential part. And they will be multiplied together in a product. So we're going to make a table, which is why it's called the tabular method. And in the left-hand column, I'm going to put a D. And the right-hand column, I'm going to put an I. Now, D stands for derivative. And we are going to write the algebraic part underneath that. I stands for integrate. And we're going to write the exponential part underneath that. And so we have our derivative part, and we have our integral part. Now here's what we're going to do. We are simply going to take derivatives of 8x as many times as we can. So the derivative of 8x is 8. The derivative of 8 is 0. We're done. Now we're going to do the same thing with the integral, with the exponential part, e to the 4x. The antiderivative of that is 1/4 e to the 4x. And now we want to do it one more time. So the antiderivative of that will be 1/16 e to the 4x. So I'm also going to put a plus here, a minus by the second row, and a plus. And we're going to alternate those pluses and minuses. So here's what we do. I'm going to go and draw a diagonal line here and a diagonal line here. Okay. And so we are going to multiply this 8x times the 1/4, 8x times the 1/4 e to the 4x, and then minus, because this is a minus 8 times the 1/16 e to the 4x. And now let's just simplify that. So the 8 and the 4 here can cancel. So I have 2x e to the 4x minus, and the 8 and the 16 can reduce to 1/2 e to the 4x. And then don't forget to put a plus c. And that is our answer. That is the integral of 8x e to the 4x. You could show this by taking the derivative of this and cleaning it up. And once you take the derivative of it and clean it up a little bit, you'll get the original integrand. And then that is the process of integration by parts using the tabular method. Let's try another example. So once again, we have an algebraic part, 9x squared, and we have an exponential part. So I'm going to have a D column and an I column for derivative and integral. And underneath the D column, I will put my algebraic part and take derivatives of that. The derivative of 9x squared is 18x. The derivative of 18x is 18. The derivative of 18 is 0. So you see with an algebraic derivative, you're going to eventually get down to 0. And this is plus minus, plus, minus. We alternate the signs, starting with plus. Then over underneath the I, we put e to the 3x. The derivative of that is 1/3 e to the 3x using the chain rule for derivatives. Then 1/9 e to the 3x, and then 1/27 e to the 3x. So you may be asking, how far do I have to go? Well, with the integral, you have to go until you get down to so you're even with the 0 here. So you're even with that 0. So you have to have 4 complete rows. Now we just put this together. So it helps to maybe draw lines through these. They go diagonal minus this product, and then we're going to have plus this product. So we have 9x squared times 1/3 e to the 3x. Well, the 1/3 and the 9 will cancel, so I'm going to have 3x squared e to the 3x. That's the yellow part. Then I'm going to have a minus 18 times 1/9 is 2x e to the 3x. That is the blue part. And then we're going to have, let's see, 18 over 27 would be 2/3. 2/3 e to the 3x. That is the green part. And then, don't forget, plus c at the end. And that is our final answer, integration by parts. Now here's one that looks a little bit more complicated, but if you understand the basic process we just did, it's just the same process over and over again. So D column, and we'll have the algebraic part here, which of course is 4x squared plus 7. And we'll have the I column, which is the e to the 5x plus 2. And now let's take derivatives of 4x squared plus 7. That will be 8x, 8, 0. And then antiderivatives, or integrating e to the 5x. Well, using the chain rule, it's going to be e to the 5x plus 2 times the derivative of 5x, or divided by the derivative of 5x plus 2. So that's going to be a 1/5. And then, not using the chain rule, I'm sorry, but using integration by substitution. We're taking antiderivatives here, so it's substitution. Doing that again, we're going to end up with 1/25 e to the 5x plus 2. And then one more time, 5 times 25 is going to be 1 over 125 e to the 5x plus 2. And so let's do this. Make sure you're going down diagonally, not straight across. And also don't forget plus, minus, plus, minus. So it looks like we're going to have 1/5 times 4x squared plus 7 e to the 5x plus 2. That's the yellow part. I think I got it all in there. I like to put the constant first, then the algebraic part, then the exponential at the end. Minus an 8 over 25 and an x and an e to the 5x plus 2. And that's the blue part. Then finally, the last part is going to be the green part, which is 8 over 125 e to the 5x plus 2. And that is the green part. And then the plus c. So it's a long answer, but we put it together just like we did in the other shorter versions. Okay, the only thing different about this one is this is a definite integral. And we know how to work with definite integrals. We just have to do it first by finding the antiderivative using integration by parts. So we have an algebraic part and we have an exponential part. So under the D column, we have 9t, and under the I column, we're going to have e to the negative t. So the derivative of 9t is 9, derivative of 9 is 0, put a plus minus plus. E to the negative t, the antiderivative of that is negative e to the negative t. The antiderivative of that is e to the negative t. And so we want to go diagonally. And that's pretty much all we have to go right there. So we're going to have a negative 9t e to the negative t minus a 9e to the negative t plus c. That's our final answer. Well, it's not our final, I'm sorry. This is a definite integral. So forget the plus c. We now have to integrate this from 1 to 1.5. And so we know how to do that. We just let this be our antiderivative in Desmos, and then we evaluate this in Desmos at 1.5. In other words, we find the antiderivative at 1.5 minus the antiderivative at 1, and that would be our answer. So we're going to, because it's a definite integral, we're going to have a number for a final answer rather than a function. In this particular problem, it looks a little bit different. And so we're going to want to rewrite this. Rewrite this as 3x squared plus 7, I'll put that in parentheses, times e to the negative 4x dx. So all I'm doing is taking the e to the 4x and moving it up to the numerator and making it e to the negative 4x. Once we do that, it's pretty much just like the last problems. So we have a D column, which will be our algebraic part. And we'll take the derivatives, 6x, 6, 0, plus, minus, and our I column, which would be e to the negative 4x. So negative 1/4 e to the negative 4x. And then a positive 1/16 e to the negative 4x, and then a negative 1/64 e to the negative 4x. So going diagonally, we have this, and then this, and then this. So that's going to look like a negative 1/4 times 3x squared plus 7 times e to the negative 4x. And again, that is the yellow part. And we're going to have another minus 6 over 16. So minus 6 over 16x e to the negative 4x. That would be the blue part. And then finally, the green part is going to be 6 over 64, and that's going to be negative, minus 6 over 64 e to the negative 4x, green part. And this is an indefinite integral, so plus c. Be careful with the signs. And of course, before you entered this as your final answer, you could reduce the 6/16 to 3/8 and the 6/64 to what? 2 goes in the 6 3 times, 3/32. So it looks like it would be 3/32. All right, that is integration by parts with algebraic and exponential terms that are being multiplied together as a product. In the next video, we're going to take a look at what you do when you have logarithms.